Well, hello everybody. Welcome. Hey, if you've ever used this formula to find the area of a non-right triangle, you messed it up, or you weren't sure how to use it, or you just wondered where does it come from, this is the video for you. Now check this out. This is the last in our series of non-right angle trigonometry. So if you're not familiar with sine rule, cosine rule, we'll leave links in the description. You can check them out, get yourself all, studied up so you can know this stuff. In this video, though, it's all about the area of a non-right triangle. Here's how we're going to do it. We're going to ask a couple questions like, why are base and height perpendicular? How do you find the height of a non-right triangle? How does sine save the day? Then we're going to do an example. And if you're a student and you would like to take some notes on this video, I've got a set of guided notes I'll link in the description. You can download, go step by step. Gets all the stuff you're learning in a nice organized fashion for future reference. And there also are timestamps in the description so you can navigate the different chapters of this video. So let's go ahead and get into it. Why are base and height perpendicular? Also, where's that 1/2 come from? What's that all about? Well, if we took a triangle like this one right here, a right triangle, and we made a copy of it in red and we rotated it, well, look what we have. We actually have right here a rectangle. Now, the area of a rectangle is, of course, base times height. But that rectangle came from two equal right triangles, so the area of each of those triangles is half of the rectangle. And the reason that base and height are perpendicular is because they are sides of a rectangle. Of course, sides of a rectangle are perpendicular because the angles of a rectangle are all 90 degrees. So that's the first big idea. The 1/2 is because the triangle's half of a rectangle. Base and height are perpendicular because they're the sides of a rectangle. All right, so now, how do you find the height of a non-right triangle? Where does that height equals sine of C sine of A come from? All right, well, if you have a non-right triangle like this one, you can name whatever side, whatever you want. It doesn't matter at all. Any way you want to do it. The only thing that really matters is the side A will be opposite of the angle A, side B opposite of angle B, and side C will be opposite of angle C. And lowercase means side, capital letter means angle. Now let's talk about the letters in the formula because those can get kind of confusing. Those A's are not the same. The A in the formula is for area. Same with the B. This B right here, that stands for base. The B on the diagram does not stand for base. That just is a name, right? So those are not the same either. So we're going to be using areas 1/2 base times height instead of using the letters. Now, next thing, base can be any side you want, right? But the height is not a side at all because it's not perpendicular. It's not a right triangle. So the way you find the height is you pick an angle, and if you take the perpendicular distance to its opposite side, that is going to be the height. So let's say, for example, we said this side was the base. Well, the opposite angle's there. So if we did the perpendicular distance from that vertex to the base, that would be the height. And it doesn't really matter which side you say the base is. The height's going to change. However, the area is going to be the same no matter how you do this, right? So area is 1/2 base times height. So let's explore how we end up finding that height right there, because we know that B is base, but what about the height? All right, so now the way we're going to do this is we actually have made a right triangle in here, right? When we did that perpendicular distance right here, we made a right triangle, and we can explore that right triangle by using sine to help us find the height. So sine of an angle is, of course, opposite over hypotenuse. If we wanted to find the sine of A, well, that would be the height of the triangle divided by C, right? Now, if we wanted to solve for the height, we could multiply both sides of sine A equals height divided by C, and there we go. So the area of the triangle is 1/2 B times C times the sine of A. Thing is, the B is the base and C sine A, that's the height. Now, the letters themselves, they don't really matter. You get to pick them, right? They're not fixed. So whatever you pick, that's how it goes. So for example, if the letters were rearranged a little bit and we had these two sides and we knew that angle that was included, then that's how we would use the formula right here. These would be the sides we'd use, A and C, and we'd use the sine of angle B. See, that's the deal. You need two sides and an included angle. So the height of a triangle is 1/2 base times height. Doesn't change even if it's a non-right triangle. The only thing that's different is to figure out the height, Well, you don't know it automatically, so you have to do a little investigation. C times the sine of A is the height. All right, so now let's see this thing in action, right? Let's go through a couple of examples right here, shall we? So here we have triangle, side of 8, side of 10.4. Which angle would you need to know in order to use the sine formula for the area of a right triangle? Would it be this one, the one on top, or the one over here? Let me know in the comment which one you think it is. Has to be the included angle, which is this one. And once you have that, all you got to do is plug the stuff in. It doesn't matter if you put the 10 first or the 10.4 first or the 8 first. Either way is fine. Just plug it into the calculator. If we round it to the nearest centimeter, we get 24 square centimeters. And it doesn't matter which set of information for the same triangle that we use, we're going to get the same thing. So, for example, if we knew this angle and these two sides, 8 and 6, well, plug it in. Same exact deal. If we knew this angle right here, same thing once again. So you need two sides and the included angle. You just plug them in, do the math right there. So this triangle, no matter which way you look at it, it's the same. We didn't see all the information at once, but it doesn't even matter. So for example, if you had these three sides and one angle, well, the two sides you'd have to use would be the sides that the angle is included with. So the sides that make the angle is what you would have to use. So you couldn't use 8, 6 in this angle. You'd have to use 10.4 and 8. Same thing here. If you had the 95.1, you couldn't use the 10.4 as the side because it's not included. And the last example right here, the 8 is not included. 10.4 and 6 are what make this angle. So this angle is included with those two sides. That's what you're going to use. So, hey, I hope this was useful for you. I hope you learned something. If so, do like all the cool kids are doing, like, subscribe, comment, share, all that kind of good stuff. Hey, if you're a math teacher, check out my Substack. I'll leave a link in the description. I have a weekly problem just for fun that I post in my classroom. It's just getting kids to do math for a different reason other than a grade. It's kind of a fun thing. I'm surprised that the number of students doing it every single week is growing. I thought I'd share them with you. My website on teachingmath.org has got all kinds of good stuff for math teachers. I also have a Teachers Pay Teachers site. Feel free to check them all out. Links are in the description. Hey, until next time, I hope you have a great day.